So in this question, we're looking at single phase AC circuits. So as with every question, I'm going to sketch out the circuit first to help explain it. So we have an AC supply here, and it's a 230 volt, 50 hertz supply. And connected to it, we have a resistor with a resistance of 10 ohms. And in series with this, we have an inductor with an inductive reactance, XL, equal to 6 ohms. Like so. And what the question is actually asking us to work out here is, what is the current flowing in this circuit, I? Now, to do this, the first thing we need to work out is we need to look at the impedance of this circuit. So just like if we're working with DC circuits where we have Ohm's law, which is, I always remember it as a very important rule, we have the relationship between the voltage, current and resistance in a circuit. So this is for DC. But because we're dealing with AC here, we're looking at Ohm's law this way: voltage, current and impedance, the letter Z. But the rules are the same as for when we use AC. We just have to be careful about how we use resistance and reactances. So if we get the overall impedance of this branch, Z, we'll be able to work out the current. So from your formula, in your AC section, you'll see that there's a formula for impedance Z, and it's equal to the square root of the resistance plus the inductive reactance squared. So they're both squared. And we have those two values here. So we can put these into our formula and get a result. So that would be the square root of 10 squared plus 6 squared. And that works out at 11.66 ohms. So we can actually redraw this circuit if we wanted as the same supply now with an impedance of 11.66 ohms. And if we want to get I in this circuit, well, we have the voltage V, we have I, so the only thing we're missing is Z. Or sorry, we have Z and we have V, and the only thing we're missing is I. So that's it. Let's get I. The magnitude of the current I, it's just going to be V over Z, the impedance. So we have our voltage, which is 230 volts, over our impedance, which we worked out previously at 11.66 ohms. And if you stick that into your calculator, you should get out 19.72 amps. So this here is the magnitude of the current. So that's the size of the current. In that same part of the question, in part A, you're asked to work out the phase of the current as well. So again, if we look in your formula book, you'll see there's a relationship for the power factor, which is the cos of the angle between the voltage and current. So it's this angle here is our phase. And you'll also see that this is equal to, in a series circuit, or over Z. So we have this value, or, from the very start. We have the value of Z now because we worked it out. So we can work out this value theta. So if we rearrange our equation, it's going to be the cos inverse of R over Z, which is equal to the cos inverse of 10 over 11.66. And if you put this into your calculator, you'll get 30.91 degrees as the phase. Now finally, in part B, so up here we start with part A. In part B, it asks us to draw the phasor diagram to scale. So I won't draw it to scale here, but I'll show you how to get the correct angles and stuff for this circuit. So when I'm drawing a phasor diagram, I ask myself, what's common throughout this circuit? So we see I is the same throughout. So I'm going to use I as my reference. That's my current I. And we know that the voltage and current in a resistor are in phase. So we can draw those on the same angle. So that would be VR. Now, how do we work out if the current lags or leads the voltage in an inductor? Well, again, if you go back to your notes, you'll find the relationship using the civil rule. So the current in a capacitor leads the voltage, but the current in an inductor lags the voltage. So if our phasors are rotating this way, that means the current has to be behind the voltage in the inductor, and it's going to be slightly smaller than the voltage in the resistor because of the size of our impedances. So again, this is not to scale, but it's just to give you an indication how you do it. So VR and VL. Now we have one more thing missing from this phasor diagram, and it's VS. So we complete our parallelogram if we want to get VS. So VS here will be this phasor here. So you can work out the exact value with the formula from your notes, but you're expecting your phasor diagram to look something like this.